Bismillahirrahmanirrahim. Okay, so in this part, I am going to show you how to do the HYSIS part of the experiment. Okay, to study the effect of coolant load. So Q, the amount of heat we take out by cooling. Okay, we change this and see the effect on the dynamics. Okay, so let's go to HYSIS. This is our HYSIS simulation model flow sheet. This is the reactor, you can see, and here we have the coolant. So we will change the coolant flow rate to see the effect on temperature and the reactant and product concentrations. So if you click this one, let's clear this historical chart. Okay, and then setup, please make sure you have this one, component mole fraction of oxide, glycol, and the diol, and the temperature. We will plot these three parameters. Okay, let's go back to the flow sheet, view flow sheet. This is the coolant, so click the coolant, then utility valve. So right now the flow rate is 2000 mole lb mole bond mole per hour. Okay, so let's run this one, dynamics, run, and while running we will change to the another flow rate. Say this is 2000. Okay, now let's make it 4000, and you can see the results here. Yeah, here is the results, and we should stop now, make the time in ascending order. So you can see the temperature started at 186 when the coolant flow rate was 2000. When we increase the coolant flow rate, temperature went down. So we are cooling more, and it reaches to the new steady state. Okay, makes sense. Now let's see the oxide. This is the reactant. Reactant was 0.002. The temperature of the reactor is decreased down. So when temperature decreases, conversion will decrease also. So when conversion decreases, the concentration of the reactant should increase. So 0.02, we should see a rise 1856, and then this temperature 142. Okay, yeah, 0.002, and you can see it rises to 0.012. Okay, and same here, the reactor product. So this is 0.24, the diol, the product. Now conversion decreases, so the product should decrease. Yeah, you can see 0.23. So what you do, you take all of this together, take this to Excel. Okay, this is Excel. Now this is time, this is time, this is temperature, and this is the concentration, oxide, and this is glycol. Okay, the time we can make it, this is like, this is the first initial time. Okay, this minus this with a fix this value, so 0, and let's see, so it's like each 60, well this is 60 second, no, so whatever, if this unit is not very clear, okay, now, and this is all same value, so we can, this one, so we can, since you have to plot, we can get it all this value when it is the same. When it starts changing, we can take from that part. Okay, yeah, here. And now it's become stable. Yeah, this one, this part also you can delete. Yes, up to here. So now we can, this is gone because again this minus function, sorry, so plot this all with time, with this time. Okay, so temperature from one acidic state to another oxide, one acidic state to another acidic state, same as glycol. So this is where you study the effect of coolant flow rate on the temperature dynamics and the concentration dynamics of the product and the reactant. That's it. Hope it's clear.